Okay, here we are in chapter 2, and notice that the screen color has changed. I like to switch back and forth so it's real easy for you to kind of differentiate between chapters on YouTube. But anyway, first thing we're going to do, bottom of page 107, definition of a solution set. Solution set is the set of all numbers that when used in place of the variable make the equation a true statement. One of the things that's very, very important when we're talking about a solution set is we're talking about the answer to an equation. Equations always have equal signs. You're always trying to find the answer. What is x? That's what you're looking for, is what number are we going to find that when we replace the variable, we get a number. So that's what we're looking at for a solution set. An equivalent equation is when we have two or more equations with the same solution. So for example, 2x minus 5 equals 9. X minus 1 equals 6, and x equals 7. These are all equivalent equations because they have equal signs and they all equal 7. So for instance, this would be 2x equals 9 plus 5. 2x equals 14. Divide by 2, x equals 7. Same is true with this one, and obviously x equals 7. So those are equivalent equations. Let's continue on here. Properties of equality. And these are really important properties. We're not going to spend a ton of time going over a bunch of properties, but I do want you to be familiar with what they mean. You already follow them when you're doing math, but just to let you know, if we have anything on this side of the equal sign and anything here, and we say that they're equal, that means the number that we put in for A is the same as the number that we get for B. It also means when we add something to A and add that same something to C, we have not changed whether or not they're equal. We've changed the value. So for instance, this was 6 and I had 6, and I changed this by adding 2, and I changed this by adding 2. They're both equal, although now they're 8 equals 8 instead of 6 equals 6. But we don't care what the values are. We just want to make sure that both sides of the equal sign are the same value. It also works with multiplication. So if we say that 7 equals 7, and we multiply this by 3 and multiply this by 3, we will get 21 equals 21. Again, the value is changed. It went from a 7 to a 7, but are they still equal? Yes, and that's all that we care about at this point. So when we're given some problems like 3a minus 5 equals negative 6a plus 1. The key here when we're solving equations like this, we're solving for the variable, we're trying to find out what a equals, is we do what is called isolating the variable. And that means that we're going to get all the variables on one side of the equal sign. Doesn't matter which side. We usually move them to the left just because that's the way we've always done it. And then we find out what number's on the right-hand side of the equal sign, and that is the value of A, and that's what we're trying to do, find out what the value of A is. So if you remember from your algebra, you add 6A to both sides. If we're trying to move the A over here, that gives me 9A minus 5 equals 1, because these go away. Now we just keep moving. We're trying to get the 5 out of there. So we have 9a equals 1 plus 5 is 6. Now we're trying to get rid of the 9. The 9 is multiplied by a, so we divide both sides. Equals 6/9, and then the important thing is don't forget to reduce, and we get 2/3. So the solution, if we were to take this number and put it in here, and also put it in there, then, and we did all the work here, and we did all the work here, we would find out that those two numbers we get are going to be equal to each other. And that's what basic algebra works with. So even when we have a fraction. Example number 2. So again, we're trying to get rid of everything on one side except for the variable. So I usually tell students, if you're trying to move things away from the variable, take the numbers that are furthest away from the variable and get rid of those first. So this one is right there, it's multiplied. We're going to get rid of the numbers that are added or subtracted to that variable first. So I'm going to take it away from here, and I'm going to take it away from here. So those go away. We have 2/3 x equals 3/8 minus 1/2. In order to combine these, we have to find common denominators. Common denominator that both 8 and 2 go into is an 8. What did we have to do to change this 2 to an 8? We multiplied it by 4, so therefore we have to multiply the top number by 4. 4 times 1 is 4. So now, instead of 1/2 that we're subtracting, we have 4/8, which is 1/2. So now we can subtract or add the opposite. And if you remember way back in chapter 1, when you're adding two negatives, you just add the numbers, numerators only, and you put the sign on there. So there we go. Now what we're going to do is we're going to divide by 2/3. So if we divide by 2/3 and divide by 2/3, these cancel because anything over itself is 1. And remember back in the olden days when you divided fractions, it was the same as multiplying by the reciprocal of the bottom number, the denominator. So that would actually be times instead of divided by 2/3. So x equals -7 times 3 over 8 times 2. And there's our answer. Leave it this way. Do not change it to 1 5/16. In algebra, very rarely do we use mixed numbers, which is what this is. We use what are called improper fractions, where the numerator, the top number, is bigger than the bottom number. So there we go. So for example number 3, we have something here, bottom of page 109, with decimals. So let me rewrite this with the decimals all in the right places rather than without decimals, and then we'll go from there. 0.06x plus I'm going to do it a bit different than the book does, but I just think it's easier that way. So what we do here is I don't like to mess with decimals. I've got a decimal there and I've got a decimal there. So what I do is I look at, and I'm going to ignore what's in the parenthesis because these two are connected. So I'm just going to look at this, this, and this here. So there are 2 decimal places to the right. So if this was actually over here, I'd be happy because it'd be 6 instead of 0.06. So I want to move this 2 over. In order to move that 2 over, I have to multiply the whole entire thing, both sides of the equal sign, by a number that has 2 zeros, 100. When I multiply 100 times this, I get 6. When I multiply 100 times this, I get 5. And because what's inside the parentheses is affected by what is here, I don't have to do anything to anything in here. And then 560, and I add 2 zeros to that. So I multiplied each of these terms by 100, or added 2 zeros, or moved the decimal place over 2. And then I can just go ahead and multiply out without having to worry about decimals, and I don't have to ever worry about them again. They're gone. They don't have to be added later. All right, so this minus this is just an x, or 1x, plus 50,000 equals 56,000. So I'm going to subtract 50,000 from both sides. X equals, those go away, 56,000 minus 50,000. And that's my answer. So I didn't have to deal with any decimals at all. I just gotten rid of them clear at the very beginning. All right, so let's jump to example 4, and then we'll be ready for a new video on solving equations by factoring. So number 4 says, so again, we're going to isolate the variable. Our goal is to get the x's together and by themselves on one side of the equal sign. So we're going to do our PEMDAS when necessary. So I'm going to look in the parentheses. Is there anything I can do to combine? No. There's no exponents, but my next step is multiplication from left to right. So I'm going to distribute that 3 . Now I'm going to combine like terms. There's no division, so I'm going to add, subtract from left to right. Only those like terms. Now I notice that I have a 12x here and a 5x there. I can combine those. I can also combine my 8 here and my positive 6 here. So let's go ahead and do that. So in red, I have a negative 7x, and in blue, I have a plus 14. Now I'm going to subtract 14 from both sides, and I get negative 7x equals 21. Let's go back to white. Divide by negative 7, divide by negative 7. Those go away, and I have x equals 21 over negative 7, or negative 3 for an answer. Next video, we'll be ready for part B, solving equations by factoring on page 111.